Who can remind me, if we are talking about an intercept, what does that mean if you see intercepts on a graph? So if we see intercepts on a graph, like here, what does that mean? What does that mean? What does that mean? You got your notes? It means that that is the point where your graph crosses the x or y axis, okay? That's what it means. And if it crosses the x or y axis, specifically if it crosses the x-axis, it's going to have an x-intercept, which is the x-coordinate, and the y-coordinate is always going to be 0. Because anything on this x-axis, if you talk about the y-coordinate, if it's there, it's not up higher, it's not down lower, so that y-coordinate is always going to be 0. Okay? Same with the y-intercept. That's where your graph crosses the y-axis. And so the y-intercept is going to be the y-coordinate. In this case, it is 0. This is a bad example. But here also, my x-coordinate is 0. It didn't go to the right or the left anywhere. So as we look at these tables, we are trying to see, where do I find any x or y intercepts? Okay, so let me read this first problem. Mrs. Anderson puts out tissues for her students at the start of each semester. The table below shows the number of this is a bad problem. You know why? We should have been talking about tissues and tissues, or pencils and pencils. I'm going to change this. You might want to also, just so it makes some sense. So she's going to put out pencils. Pencils for her students at the start of each semester. The table below shows the number of pencils remaining each week. So, week 0. Okay? Week 0, number of weeks. This is your domain. These are all of your x values, which means over here, instead of tissues remaining, we're going to say pencils. And this is your range. Now, as I just said, anytime you see a pair of numbers, so this would be the pair 0, 153. That's an ordered pair. That's the x-coordinate and the y-coordinate. The next one would be 1 and 125. Okay? And then 282, 364, etc. All right? Anytime you see a pair that has zeros, those are your intercepts. Those are your intercepts because there is a 0 in either the x-coordinate or y-coordinate space. So here, my x is equal to 0. My y has a value. So that means this y value is the y-intercept. Okay? Whenever the number comes up, if it's in the domain and the number comes up in the domain and the range has the 0, then that is the y-intercept. Over here, in the domain, we have 5. After 5 weeks, there were 0 pencils remaining. So 5, this is your x-coordinate. It is also your x-intercept because that's where you have the value. 0 is just the y-coordinate. This is where the x-coordinate is. So it says, what are the intercepts of this function? The x-intercept. X-intercept has to have an x value. So that's going to be 5 right here. And the y-intercept is the pair where you have zeros. but it's the y coordinate, which is right here. So that is 153. Questions on that? So you've got to look and find, where do I have a pair with a 0? Okay, those are your intercepts. Now, then it says fill in the blanks with the meaning of each intercept. So I want you to take these numbers and look at whatever the description is for the domain and range. Okay? So we are looking at 0 and 153. This is the y-intercept, right? Well, what does that mean? When you look at the x-coordinate, we're talking about the number of weeks. If no weeks or 0 number of weeks have gone by, what time of the year is that? It's the beginning of the school year, right? So we can say at the beginning of the school year or at 0 weeks, you can say that too. So right here, this is your number of weeks, and this is your tissues remaining. You can label those. So when it says, what's the description? At 0 weeks of school, there were 153 tissues remaining. That is the meaning. I don't want you to say it's the x-coordinate and the y-coordinate. You need to tell me what's happening as part of the problem. Okay? Now let's look at the x-intercept. The x-intercept is going to have the x-coordinate, which is 5, 0. Okay? 5, 0. So 5 has to be the domain. That's your number of weeks. Number of weeks. And 0 is pencils remaining. I said tissue, didn't I? So that is, hang on, tissues, pencils remaining. So what does that mean as you look at it? That would be at 5 weeks of school, or after 5 weeks of school, comma, there are 0 pencils left. At 5 weeks of school, there are 0 pencils left. And you can see through this table, that makes sense. As the weeks go by, people need to use pencils. Maybe they forget it. Maybe it broke. So the number of pencils remaining goes down. Yes? Not right now. I'm in the middle of teaching. You've got to go and ask me sooner. Just wait. I'm right in the middle. Not right now. I didn't say no. I said not right now. Are there questions about that first problem? All right, let's take a look at the second one. Kristen gets a gift card for her birthday. Below shows the money remaining after each, boy, we really messed this up. After each, we'll say transaction. So we need to add the word transaction here. After each time she purchased something. So this should be not number of weeks. Let's put number of transactions. And instead of pencils remaining, this would be remaining balance. So she's got a gift card and she's going to make purchases. And every time she makes a purchase, that number is going to go down. Okay? All right. So first of all, I want you to circle. Jasmine, come on. Please get your head up. I want you to circle where you see an ordered pair that includes a 0. I want you to circle that. That would be here and here. Remember, the top line is usually going to be your domain. And the domain is your what values again? The domain is your what values? X values, thank you. And the range is going to be your Y values. So those are my intercepts. 120 is one of them and 5 is one of them. Which one is the x-intercept? The x-intercept is in the domain. So which one is the x-intercept? Angel, what do you think? Which one is the x-intercept? X-intercept has to be associated with 0, right? Andre, can you help him out? Yeah, 5, 0. The domain is the x-intercept, so I have to have a value where the y-coordinate is 0. So the x-intercept here is 5. And remember, we don't have to say the 0 part because everything that has an x-intercept has a y-coordinate of 0. And so what is my y-intercept? Anyone? 120. So you look in the range where the y is. You have to have an x equal to 0, so that is going to be 120. Are there questions about that? Does that make sense? Would you be able to do this on your homework tonight? They gave you a table. Could you find the x and y intercepts here? Now we're not quite done. It says fill in the blanks with the meaning. So for your x-intercept, I'm going to start over here. It is 5. But remember, that's really 5, 0. So that is, as you look for your domain, number of transactions and then the balance. So I would say after 5 transactions, after 5 times where she bought something, Kristen has $0 left. That is the meaning. Do not tell me 5 is the x-intercept and 0 is the y-coordinate. Don't tell me that. I need to know in terms of the story, in terms of this word problem, what does that mean? Okay? The y-intercept, right here, we already said, is 120. As an ordered pair, that is 0, 120. So as you look for that 0, 0 is the number of transactions, okay? At 0 transactions, if she hasn't made any transactions, that means she probably just got the card, right? So at 0 transactions, bleh, easy for me to say, she has how much left? How much money does she have? $120. She has $120 on her gift card. Questions on that? All right. Let me take a look here because we're kind of at a stopping point, but I think I'm going to press on just a little bit. So, intercepts. Now we're going to talk about extrema and end behavior. Extrema and end behavior. Okay? Extrema. What does that word sound like to you? Extreme. So we're talking about our extremes, the highs and the lows of a graph. Okay? Extremes. Thank you. So extrema is similar to your extremes. Graphs or functions can have high and low points where they reach a maximum or a minimum value. The maximum and minimum values of a function are called extrema. The maximum is the highest point, okay, on the graph, and the minimum is the lowest point. Okay? Now, we have absolute extrema and we have relative extrema. So, absolute extrema is both the highest and lowest points on a graph. Both the highest and lowest points on a graph. The highest and the lowest points on a graph. Whereas relative extrema, yeah, there's a part or a time where it goes up a little bit, but that point where the graph goes up is not the highest. It's kind of like a hill, okay? Relative extrema are, let's say, small, I'm going to say small highs and lows. Small highs and lows of a graph, but not the highest and lowest points. Okay? So small highs and lows of a graph, but not the highest and lowest points. These are our notes that we're on right now. Is everybody done copying that down? All right, so let's turn the page and let's see if we can find some absolute extrema and relative extrema. So here we have a graph over to the right. Take a look at this graph. First of all, it's not even up here. Is this linear or nonlinear? Nonlinear. That is not a straight line. Nonlinear. Okay? Michael, let's go. Nonlinear. Not a straight line. Yes. In just a minute. I gotta take care of something first. I'm disappointed. All right. Find the extrema from the graph provided. If it does not have one, put none. Minimum. Minimum is the lowest point. So as you look at this graph, does it have a lowest point? Yes or no? Come on, guys. Need you to answer. Does it have a lowest point? Yes. That lowest point is right here. We would call that the minimum. All right. What is the value of that point? What are the coordinates of that point? It's on. That is correct. It is 0, -5. Because it is the lowest, is that a relative or absolute minimum? Is it the lowest point? So it is absolutely the lowest point, or is it just kind of a small dip for the graph? It is absolute. So this is an absolute minimum. Okay? Maximum. Maximum. Do I have a highest single point for this graph? No. So there is none. And if there is none, then I can't label it as a maximum or relative or absolute because there is none. Questions on that? All right, let's take a look at the second graph here. Take a look at this graph. First of all, linear or nonlinear? Nonlinear. It's not like a line. If I wanted to check and see if it was a function, what would I do? What would I use? Vertical line test. Think of Men in Black. If you know Men in Black, they put this up. Vertical line test. And if I draw a vertical line, is that a function? This is not on there. I just think it's kind of good review. Yes, it is a function. It only crosses in one spot. Is it a one-to-one function? One-to-one function. Is it crossing that horizontal line just once? No. So it is not one-to-one. Bless you. All right, so now let's get back to the lesson at hand. Minimum. Minimum. That is your low points. Okay? Low points. How low can you go? Do I have any minimums? Now, it's not talking about lowest. It's just saying low point. So do you see a place where it is dipping down? Yes. The answer there is yes. So a minimum would be right here. Now, it is not the lowest, but it is a low point for that area, right? It's a dip, okay? So you can talk about lowest or dips. And that point is 0.4. 0.4. Now, is that a relative minimum or is that the absolute lowest point of this graph? It's relative. It's relatively low for that area, but it's not the lowest point. We don't have a lowest point because this keeps going on and on. So this is a relative minimum. A relative minimum. Okay? Maximum. We're looking for high points. Could be the highest, could be just kind of a point that is up a little bit compared to the surroundings. Okay? Do you see any maximums? We've got one right here. Well, if I can keep my pen to write. Because that point here at this green point is higher than the other two sides on either side of it. Okay? So that point is -2, 8. -2, 8. Is that a relative or absolute maximum? Is it the highest point of that entire graph? No, because see that arrow keeps going. There is not going to be an absolute maximum, but it is relatively high for the area around it. So this is a relative maximum. Okay? So if it is the absolute highest or lowest point, it is an absolute maximum or minimum. If it's a high or low point in the general area, then it is relative. All right, we are going to stop there for the notes today. Please take out your homework number 1. I want you to be working on homework number 1.